So in translation motion, we have a truck over here and we have a car over here. So both are at rest. You want them to move. Okay. So where you need to apply more force? This truck has weight of suppose 2000 kg. This car has mass of 500 kg. So where do you need to apply more force? Who has more moment of inertia? Who has more inertia?
Truck.
Yes, who has more inertia? Truck of course have more inertia due to its mass. More is the mass, more is the inertia. So inertia of truck is definitely greater than car. So you need to apply more force to move the truck than the force required to move the car. So that's how the mass plays the role. The role of mass plays in the motion. So more is the mass, more is the force required. Now, same role for the translation motion. You have this rod. So you have this rod. You want to rotate it in anti-clockwise direction. So you have two rods. One is mass 1 kg and another is mass suppose 10 kg. So you want to rotate both of them. So tell me where you need to apply more torque. Students, don't sleep. If you want to learn physics, you need to be active. Where do we apply more force? In case more torque, in case A or B? So here there was no formula to tell the inertia and mass, but in rotational motion we have the formula, and that formula is I equals to suppose we have the formula for a particle. For others we will write. So for this is suppose a particle on the extended body. The inertia for all the particles will have different inertia. So inertia of this particle P is m r square. So r is the distance from axis of rotation to point P. So that's the inertia here. So we have the formula. So of course, so it also depends on mass, but moment of inertia decides whether you will be able to rotate this body or not. So the role that the mass was playing in translation motion, same role moment of inertia plays in rotational motion. So moment of inertia doesn't want the rod or any extended body to change its rotational state. So moment of inertia means we are not talking about rotation translation, we are talking about rotational state. So here we were talking about translational state. So moment of inertia, more is the moment of inertia, more is it difficult to rotate the body. And you can see that this moment of inertia clearly depends on mass, and r means the distance from the axis of rotation. Okay, so these are the two important points. So now if you have now let us find the kinetic means the moment of inertia of this extended body. What will the moment of inertia? So if the body is moving and has more inertia, it is difficult to stop. So it is difficult to change the state. If it is at rest, difficult to change the move it, and if it is moving with constant velocity, then it's difficult to accelerate it, means increasing the speed or decreasing the speed or changing the direction, whatever. But in case of similarly in case of inertia, if the body is rotating, so tell me, if you have this tire rotating and this tire rotating, so where you need to apply more torque to stop it? This case C, this is case D. Where you need to, so both are rotating, so where you need to apply more force? Which one is difficult to in which case is difficult to change the state of this? So this is
D.
wheel, and this we call this bigger one as flywheel. So it's difficult for flywheel to move, but once it is moving, it's difficult to stop it also due to moment of inertia. Now the kinetic energy of the motion of suppose we have n number of particles over here, so let this be the ith particle. The body is rotating, so we can consider this body which is rotating, and this is ith particle at point P. So what is the kinetic energy it is possessing? Kinetic energy is equals to half mv square. So it is ith particle, so its mass ith and velocity ith, and we know that v is equals to r omega, so that we have already done. So v is equals to r omega, or omega into r. So here this and this, you can take the as we have derived it, it doesn't matter whether you are taking r perpendicular or r. So that is why we always have this formula, v is equals to omega r, because this r perpendicular and this velocity which is tangential, there is always an angle 90 degree between v and r. So the angle is always 90 degree. So that is why the magnitude of linear velocity is equals to angular velocity upon r, and you know the angular velocity is equals to d theta by dt at any moment. Okay, so putting the value of vi is equals to ri and omega I, ith particle. So what will the kinetic energy of the whole body? So kinetic energy, you know, this is scalar quantity. So scalar quantity we can simply add. So we are simply adding the kinetic energy of all the, and you know that kinetic energy is always positive. So k is equals to summation of this k. So summation of this k, that's the total kinetic energy of the body. So k is equals to summation this k and summation of this. So here we know that for all the particles angular velocity is same, but linear velocity is different. So angular velocity is same, so omega square is coming out of this summation sign, and we are left with half k is equals to half omega square summation mi ri square. But we know that now this k is equals to this we want if we compare that k is equals to half mv square. So here this half is there, yes. This velocity, linear velocity and angular velocity square, yes, it is there. So instead of mass, I have this mi square. So this I am taking as it as a moment of inertia. Okay. So therefore I can write it. So where moment of inertia is I equals to this. So I replace this with I. So that's your moment of inertia. And that is why I have written over here from this point only, that for a particular particle moment of inertia is equals to mr square. So I got it from here. Okay, so for a particular particle whose mass is m, any point particle, you can write the what does this mean? This means m1 r1 square plus m2 r2 square plus so on. So if there is only one particle, then there will be only m1 r1 square. So I is equals to m. So moment of inertia of a particular particle whose mass is m and at a distance r from the axis of rotation, then I is equal to mr square. So this is now you have understood what is the meaning of moment of inertia. It doesn't allow a body to change the rotational state. Okay, more is the moment of inertia. So we need to have the different bodies have different moment of inertias. So that we need to calculate. Okay. Anything you would like to ask that we have studied till now? Okay. Yes, Mansi, Harsh, Gaurav, Randhir, Joel, Tushar, Vinay, Lakshay, Kartik, Prashant, Sakshi, Kashish.
Excuse me, sir.
Yes.
Sir,
Why
if
don't
it
you rest of you people speak? Switch on your cameras.